All right, here we are taking a look at purely focusing on Auth. So I've got this app here that's supposed to be like a Twitter-like clone called Blurbs, where we make little blurbs of text. And so I've gone ahead and set up the backend for, a CRUD app just without Auth. So we've got our database code all set up. Got all of our queries written for our blurbs. We have all of our API routes written for our blurbs. And that's pretty much it thus far. So we just have a very bare bones server. I haven't even touched client-side code yet because that's all going to be a separate video. But this is what we have thus far. And I do have everything committed and saved in a Git repo that I will put in the description. But as of right now, if you're wanting to browse the repo at this specific point in time with GitHub, you can click on the link of commits and it will let you click this specific commit so you can see all of this code at this point in time before I make any, subsequent commits on this. And so that way, by the time I'm finished recording this video or these videos, I would have several commits ahead of this, but you can still jump back to this point in time with GitHub. So, but yeah, let's go ahead and start adding Auth. So one thing that I do want to look at first is in our routes. When we're creating a blurb or a post or, a blog or a chirp, whatever you have of some kind, we want to associate that with some kind of user. And you may have just been hard coding a user ID of some kind just because, well, up until this point before Auth, you don't know who's actually making a request. And so just hard coding it as one or the ID of literally any user that currently exists in your database, is what we would go with. But we obviously don't want to, do that. We want to be able to actually certify, who made the request. So we have to add auth to this. So where do we even get started? Well, in my database, I've got a couple of tables. We're keeping it pretty simple. I have just my blurbs. They've got their ID. They've got the user ID that they're linked to. They've got content. And then they have a couple timestamps for when it was created and if it was edited. For the users, they've got their ID, email, password, and created at. And that's it. Oh, kitchen. So, sorry, my cat chewing a cable and knocking stuff off the desk. I forgot where I was going. Oh yeah, so we need to go ahead and start creating some queries to associate and attach to our users table. And so I'm going to make a users.ts file in my queries folder and go ahead and start defining those. So we need to import our query function. And I've got a couple of types for users. We've got my user type and my creatable user type. And really, for an app of this small scale, I don't need to do all queries for a user. I really just need to be able to create a user and to find a user, aka, what we use in the login process. Search one by an email, or maybe an ID, or maybe a way of flexibly handling both. You could also throw in a delete if you wanted, but, for this, I'm keeping it minimal so we can focus on just the core auth concepts. So here, I'm going to make a create function, or if we wanted to, just for semantics sake, we could call this register, because that's kind of what we're doing. And so it'll take a variable named new user, whose type is of the creatable user type. And we'll say insert into users set question mark. That question mark placeholder with the set keyword allows us to give an entire object as our argument, which keeps things simple for us. We don't have to send email and password as, separate things. We can send them as one object when we call the register function, which is, kind of helpful. It definitely makes our SQL here a lot more straightforward to use. So that is why I always prefer it, but it also has some other cool implicit benefits down the line. So we've got the ability to interact with our database, with our users table, to provide an object with an email and password and actually create a user. And we also need to be able to find a user for our login. And so it kind of depends on what you want to do, but you could have a find function that takes an ID. You could have one that finds by an email. If you have usernames, you could have one that finds by username. And so you could technically have like 3 separate ones. You could even have, with a MySQL library, a way of allowing 3 functions to consolidate into one. I don't use that too terribly much, but I'll show you what I'm talking about. This is what we do show in the lectures as well, but we're going to go ahead and write our select statement here and say select all from users where, and then I want this find function to be able to find a user by either an ID or an email. And so we've got this argument called column here, and you can actually have it use columns as an interpolated variable. Now, since we're not just looking at like values of stuff, since we're actually trying to use columns, they have to go through a special escape sequence where we use 2 question marks. And so you'll see something like that. And what that means is I can now call the find function here. And I can say, okay, well, I've got ID. And actually that should be a string or a number, because technically with our app we have number IDs. So this function, I can say, hey, find a user by what? Select from users where ID equals 5. We can use it this way. We can also use it this way. And in theory, if we had other, columns on our user table that we could use to search our user, for, if we had like a username column, for example. You could use something like that. So this function is actually really versatile. Now, like I said, I want to keep it nice and simple. So instead of having this dynamic function, which is very cool because it lets you do this in at least the apps that you've built thus far, we're just going to keep it nice and minimal here and just give it an email. And so we know that I'm only ever going to provide the email string here. And we'll go ahead and type this function as returning a user array. And so even though, we know we should only get 1 user back, our database code can't tell that ahead of time. And so every select statement always returns an array. So even though we know we only have 1 thing coming back, it's going to be 1 thing inside of an array. But those are just the 2 database functions that we need for our users for Auth. At, it's very bare bones, most minimal. So we've got that, and I've got those functions exported. What I'm going to do is go to my database folder index, and we're just kind of, we don't have to have a database index file like this. It's just convenient for importing and exporting. So for instance, if I want to use some database queries in a route, I just import db from ... whatever, db. If we didn't import everything into the index file, it would end up being something like import blurbs queries from dot/dot/db/query/blurbs. And so it just kind of reads out in an ugly fashion. Like, this works. This is effectively the exact same thing as the above. It's just a little uglier. And plus, if I wanted to also do something with users or another table in this file, if you wanted to use two different table files, two different query files, you'd have to do two separate imports. With the giant index that we import, where it's got everything nested within it, you know, that's all we need. This gives us the ability to basically use any query we've written in our entire folder from just one import. So it just kind of keeps things clean reading, and it makes our lives a little bit easier. So we'll come here. We'll import our users queries, and we will export those out. So thus far, we still really haven't done like anything auth specific yet. We're still kind of just doing some general database and route setup, but I didn't want to touch any auth code yet until, we, got to this point. So let's go set up our auth routes. So I've got my routes folder here with an API folder for all of our API routes, and then an auth folder for all of our auth routes. There's nothing currently in that, so let me go ahead and create our auth index. And we'll go ahead and create a router here and make that the default export of this file. So there's nothing really going on in here at the moment, but it is something that I did create, and it's exported, meaning it's now importable. So one thing I like to do is I like to create my routers, and then immediately before I write any further code is go import them where they need to be, imported. And that way I know for sure everything's linked up correctly. So I've created my auth index, and I told my server, like, hey, when somebody makes a request, look at this file here to say, like, okay, which folder do they need to go to? If the route starts with API, go to the API folder. I also want to tell it, like, hey, if the request starts with /auth, go to the auth folder. So we'll go ahead and we'll import that, empty but still importable router that we just created a minute ago, just to get this linked up. And that means that, later I don't forget to, link it up, because typically I forget to do that a lot. And then my code's like, hey, that route doesn't exist. And I'm like, I've been working on that route for like 30 minutes. I'm pretty sure it does. And it does. I just didn't link it up. So now our routes index file done. We don't need to do anything else with it. We now say, like, hey, our server's like, hey, I've got a request coming in, begins with API. This says, okay, go look at that API folder for further instructions. Oh, you're beginning with auth? Okay, we'll go to the auth router for further instructions. So here we are, auth router. And if you want, you can create separate files for all of your auth routes. And I really do recommend that on larger projects. So you probably would have a login.ts and a register.ts, at least for your labs, which I would suggest just because it's a better, cleaner practice. And especially on larger projects, you're not going to have just, two auth routes. You might end up having 3, 4, 5, 6, 7, plus for some extra additional auth functionality. So if you try to cram all of that into one file, it's going to be really hard to, decipher if you've got it just crammed in one file. That being said, for demonstration's sake, I am actually going to take what we normally would put in a separate login and register file and just keep it here. And that's just so you've got an easier kind of comparison, an easier frame of reference. So, two things. One, we need to first be able to register users, because right now my database is completely empty. I can't create a blurb yet because a blurb requires a user ID, and I don't have any users yet because, well, I haven't been able to, well, register a user. So that is our first step where we now finally get to implement some auth. So in here, I'm going to make a post request. The path already begins with /auth. And so for me, /auth/register sounds kind of like a good, request path for a registration attempt. And I mean, that's just kind of a pretty common convention, so we'll stick with that. We'll go ahead and import our database folder, and that way we can access our user queries in a minute. I'm going to set up my try-catch block here for our registration attempt and go ahead and handle our error first and foremost, and that way, no matter what, if I screw up some code later, I know that I've got all of my, error handling at least taken care of, and I can find the error a little more quickly. So we will first go ahead and log out the error, and that way in my terminal I can see, an error if it happens. And then we'll go ahead and send a message back to the user. So we will send a response with a status code of 500 indicating some general server error happened. We don't really know what happened. We're in a catch block, which can catch really any type of error happening. Now, realistically, we're only going to have a few lines of code in here, and so it's pretty much just going to be a database error. So we kind of have a general gist of what happened, but in larger projects you won't. So this is kind of just your default, like, oh crap, something broke. So I might just put like a super general message here for now, like can't register, try again later. The database could have been overwhelmed. There could have been too many connections to the database at once. Who knows, so at least having it logged out will let us kind of identify the root cause. So now that we've got that, what does it take for us to register a new user? Well, looking at our user table here, what's getting created and set up by the database is the ID. It's setting that up and incrementing that automatically. And then it's also setting up the created at timestamp. So we don't really need those two. When we're registering a user account, we just need two things, the email and the password. And I did, this is something I do want to highlight real quick. Your email here. This is effectively an ID in and of itself. You want to absolutely make sure that you've got your email marked as unique, because otherwise, well, what happens if I also register for an email account on Blurbs or Blurber or Blubber, whatever I want to call it? What if I register for an account using your email as well? Then I can make blurbs that look like they came from you, but they actually came from me, and I could be saying all kinds of terrible things, and that's not great. So emails definitely should always be a unique column. So we need an email and a password, and so that's going to be coming from the request body. So let's go extract those out. And at the very least, I'm just going to check to see that, let's see, well, I'm going to check to see if email is not truthy. So if it's not truthy, it's because it's either missing or it's some other falsy, value. An empty string is a falsy value. So if they don't send an email, or if they do, but it's just like an empty input, that catches that. What if they send an array of numbers? Well, an array of numbers is truthy, so it does skip past this check, but it will fail this check. I want to make sure, like, hey, if the type of that email variable is not a string, like you're sending me garbage data, I don't want to try to, put an entire array in my database for the email field when it should just be like a single string. And in addition to that, we can also check for like maximum and minimum lengths. So, our database, if we didn't do this check here, if I try to give it an array, it would be like, whoa, shit data. But it would throw an error. This would be a very generalized kind of thing. Our users wouldn't exactly know what happened. They would just see like couldn't register at your account at this time. So the intent of this is for us to kind of preemptively like grab potential errors that could happen with our database. And although our database would not let garbage data get in, our users wouldn't know the root cause. And so if we can kind of preemptively like understand what possible errors could crop up, at least with bad data, we can intercept that and send something that's a lot more targeted for our users. So that's the intent of this. So I'm checking to see if email at least exists, that it's a string. And I also want to make sure that it's not too short and it's not too long. So we can check to see if the string length is less than like 7. I think that's like the shortest possible email you can have. And in my database, I set it greater than, or I set it to 128, I think. Yeah, so, I mean, you don't really need to support emails that are too much longer than that. So just want to make sure that we've got a string that exists and that's not too short and not too long. This really is pretty bulletproof with just this if statement here. Like if I'm a potential, if I'm trying to like hack your app, if I'm just trying to see the kind of what vulnerabilities you have, I might send a bunch of garbage data when trying to register a user, and this is just going to prevent that from happening in the first place. So what we're going to do is we'll send a response here with a status code of 400, which means bad request, and that's basically your server saying like, hey, it's not my problem, it's yours, client side, you figure it out. And so here we can have that kind of preemptive cutoff for our users and say like, whoa, hey, it's not a general error. We know exactly what happened here. Email is required and must be between 7 and 128 characters. We also need to return here in the event we have bad data, and so that way our code doesn't continue processing before that happens. So I'm going to do that. And then we will also do something somewhat similar for your password field. So actually we can just kind of copy paste this validation and change email to password. So I want to make sure that password exists. That password is a string. And I might go ahead and, check a few minimum and maximums. Why not? I want to make sure let's say, 10 characters. I want to make sure my passwords submitted by my users are at least 10 characters and they're no more than 200. I think that's excessively generous. Now, with Auth, it's never going to be 10 characters or 200. With our hashing and salting process, it is always going to be the exact same output, 60 characters. So the maximum length doesn't really matter all that much, except for some like really weird esoteric like attack forms, but you don't want to allow your users to submit like an entire book as a password, basically. That could cause like, that might just take a while for your database to, process. It's going to be a lot of extra net bandwidth on your, Express server, just dealing with larger and larger variables. So we're just keeping things to a very reasonable limit, in my opinion here. So let me change this up. Now, I want to create an object that just packages email and password backup. So I'm going to say new user is equal to an object with an email and password property, and the value of that email is this email variable. Same thing for the password correspondingly. Now, what we absolutely cannot and should not do is just insert this into our database as is. because if I do that, what I've just done is I've put our user's plain text password here in the database, which is never, ever, ever what we want to do. If we do that and our database gets breached, they're probably going to have a few other accounts that get stolen because users are predictable. People use the same password for multiple services, which is a terrible practice, but it happens. And so we don't want to be responsible for those kind of attacks continuing to propagate, which is why we hash and salt our passwords. So we cannot do this directly yet. So what we need to do between here and now is actually securely store and save our password. So we need to install the bcrypt library for that. So let me go open up my terminal. And we'll go ahead and install bcrypt and its types. Bcrypt is a library that wraps around the blowfish cipher, which is just the encryption library. B for blowfish, and then crypt for cryptography. But we'll go ahead and import that here. And the bcrypt library takes care of all of the heavy lifting for us. So I spoke a little bit about like salts and hashes in very general terms. Let's see. So if you go back to re-reference this, it's, heck, you know what? I'm going to go ahead and just show like the live output of this. I'm not even going to, register users yet. So with hashes, one input is always going to produce the exact same fixed output. Password 123, when put through a specific hashing algorithm, is always going to produce the same output, no matter what. So we can't just purely hash our passwords, because that means if you register with password 123 and I register with password 123, it's going to look like this in our database. Both you and I are going to have the exact same, password. And so if my database does get stolen and somebody does see that, roughly 10% of my passwords are this, if they can just guess password 123 for my account and they find out that that's what that equaled, then every account that has that as their password, they now know also used password 123. So it's really easy to reverse engineer a database with just like a frequency list of commonly stolen passwords. So that's where salting comes in. You basically get a secondary additional password added on. And so if you and I both register with password 123, you might have a random salt here that's, like these 6 letters, and I might get these 6 letters. And we effectively have that combined onto our password itself. And with hashing, one input always produces a fixed output, but any change to that input produces a dramatically different output. So what I'm going to do here is I'm going to go ahead and I'll show you like the salts and everything in our console logs. So I said we're not going to go ahead and do anything with our, users just yet. I'm just going to bounce back our input, but we're going to go ahead and create a salt with bcrypt. So we're going to do bcrypt.gensalt. We'll use a synchronous function here. I talked a little bit about salting rounds here, which is the amount of times that it's going to rehash over itself to the 10th power. So if your number of salt rounds here is 10, that means it's actually going to rehash it 2 to the 10 amount of times, which I talked a little bit about, here for complexity. It's done as an attempt, or it's done to kind of really stop brute force like password cracking attempts. It's going to slow down requests a lot for somebody that's trying to like brute force their way into an account. But for your average legitimate user, adding on a little extra time is not going to be anything perceptible to them. So if it takes, if we do something like 12 or even 14 here, which like that's a really, really long time. Industry standard is still 10 with a little shift over to 12. 14 is really long. That might be like a second and a half, Still, that's not too terribly long for somebody registering a brand new user account. Like you kind of expect that to take time, but that is devastatingly slow for somebody trying to do like a brute force attack. So that's kind of what this is doing. So we're creating a randomized like part 2 password, but also in a very deliberately slow way. So we've got that. What am I doing? So we've got our salt, and now we're going to go ahead and create our hash. So we're going to do bcrypt.hash sync here, and we're going to provide our plain text password, and we also need to provide our salt or salt rounds. Since I created the salt separately, we'll give it here to our hash sync function. So we're basically telling bcrypt like, hey, here's our user's original password. Here's that salt, aka that secondary randomized password. Smash them together and then hash them. And then that's our resulting string that gets stored to our database. So let's go ahead and I'm going to fire up Postman. Let's see, is my server actually running? It is. So all we're going to do is I'm just going to send an email and password, and it's just going to bounce that password back, but also the salt and hash. And I do want us to note the differences between each one of those between requests. So I'm creating a new collection here in Postman for this since it is a new project. So we'll go over to collections. I'm going to name this collection blurbs. I'm going to add a folder here. I'm going to call that folder auth. And then I'm going to make a new request called register. I'll change that to a post request. And then our address here is going to be localhost 3000. And I said our path would be /auth/register. That's what we set up with our routers. So just kind of following common convention there. Our body is raw JSON. Email is, and I almost just wrote the word foo, but that would have been too short. Our validation would have been like, hey, you're sending in garbage data. Not going to allow that. Actually, let's see that. And then our password, I said we actually had a minimum of 10 characters, so let me make that long enough. But here, there we go. Somebody's trying to send in crap data. Instead of letting our database accept that crap data, we're like, hey, that's got to at least be like the right length of an email. So now, what I want us to look at is the original input here was all these A's are actually, is that long enough? 811, yes it is. So we've got our password, our plain text input here. We've got our salt, which is our randomized password. And then we have our hash. And I want us to kind of observe in the logs, if we look at our, hash and salt here, note that, interesting, in our hash, the first half of it is our salt. And so with hashing, everything is a one-way process. We can't necessarily reverse a hash, but when a user is logging in, how do we, know if they're legit? Well, we get their entire hash from the database. We say like, okay, well, somebody's saying, hey, I'm the user with the email andrew@covalence.io. Here's his stored hash. He's attempting to log in with the plain text password of password123. The stored hash, we know that the first X amount of characters in it are the salt. So we can take the salt, we can take the plain text password, I'm trying to use password123, and using the instructions here in the salt, $2b means the Blowfish cipher version 2, $14 means the amount of salt rounds. The bcrypt library can say, okay, with these instructions, and then the salt and the plain text password, it's going to go through those over and over again until it can produce this. And if everything matches up 100%, boom, you know that that plain text password plus the stored salt equals the entire stored hash, and therefore that person's logging in and they are who they say they are. So that's a little more in depth on like the theory of like how logging in works, but I did, want to show this here so that way we could see it. Now let me copy this hash here. And remember, I just quote unquote registered with a password of password123. I'm going to do it again. But let me paste the first one here. And let me go grab this one, the second one that I just ran. So our salt is the first, set amount, like roughly the first half of the hash. So my plain text password was password123. I got this randomized salt for the first one, and this is the hash that was produced. Second password we created, password123 was still my plain text one. Here is the randomly generated salt for that, which is very different from the first salt. And consequently, our hash here just dramatically different. If I steal, or if my database gets stolen, and it's just two users, me and you, and we both registered with password123, there is no way anybody can possibly tell that we both had the same input password just because of that extra bit of randomness. So that's kind of just more in depth of what salting and hashing actually are and what they're doing for us. And so, yeah, that hash, that's what we got to store in our database for precisely that reason. So if it does get stolen, it sucks, there's a lot of stuff that you have to fix in your application if that were to happen, but you can at least rest assured that your user's information is at least, secure. So, or at least their passwords are. So now that we've done that, let's go ahead and actually make the user account in our database. We don't want to send that plain text password. So I'm calling the register function and I'm giving it this new user object. That new user object has the plain text password. We do not want to send that. So what we're going to do is just replace that. So new user.password used to be the plain text. We're just going to go ahead and change that and say, hey, new user.password is actually the hash now. So we are going to overwrite it. And then we're going to go ahead and register that user. And so that is our salting and hashing in action. And then we'll go ahead and bounce a message back to our user, letting them know that they did successfully register. So now that I've done that, when I go to Postman, instead of me just like bouncing info back, we are actually writing a user to the database. So let me go create a real user. Test@test.com. Password123, going to create that user. And I'm going to create a couple more accounts. And they're all going to have the same password, the same plain text password. But let's go look at the database. if I look at my users here, and by the way, the app I'm using here, it's called Beekeeper Studio. It's effectively the exact same thing as what Workbench is, or what it's doing in theory under the hood. It's just a little nicer to look at, and I prefer teaching with it because I can zoom in on results a little bit better. But what you're using, exact same as what I'm using effectively. I just like how this looks. But, you know, here are the 3 user accounts I just created, and there is just no way to tell, due to our salts that were randomly created for each user, that the original input password was password123. So, boom, secured. All right. So we've got registration down, which means we now have users with user IDs, which means we can now like actually create stuff in our app using those user IDs instead of just hard coding it. But first, we have to be able to log in as those users. So how do we log in? Well, we're going to start off with making a login request. And like I said, you should, in, you know, other apps like you did with your, you know, lab, create these into separate files, especially, you know, because on larger projects, you're going to have more and more, you know, auth files. But I am keeping these 2 contained together in the same auth index file just for, you know, convenient comparison between the 2. Just like with register, I'm going to go ahead and take care of my errors first. So I'm just going to copy my catch block here. And just kind of do a general, you know, couldn't log in, but at least we have our error logged out server side, so we can check and see everything in our terminal, and our users have some indication that something broke. So, when we're logging in, just like with registration, when you're logging in, what information do you send? Well, your email and password. So I'm actually just going to go ahead and copy paste that in here. So we're extracting our email and password from the rec body, and we're doing the same checks here just to ensure that, you know, if I register with good data, that I don't try to log in using crap data. We just want to make sure we've got, you know, consistency of our app's behavior. So that way, if, you know, a user registers and they try to log in, but they leave their email off altogether, we at least are like, hey, you can't, you know, log in without an email. So once we've done that, how can we go ahead and do that, you know, password checking? You know, how can I say like, hey, somebody's trying to log in and they're claiming that they are test@test.com. They are claiming that their plain text password is password123. You know, how can we actually validate that? Well, we first need to go ahead and make sure that user account exists. So what we're going to do, so wait, db.users.find, and we're going to use that find function, which for this app, I specifically made it only look for an email, but in the apps you use, you maybe made it dynamic to where it can search for an email or an ID or a username. So just be sure you're using, you know, whatever you've got set up, you know, built for your app. But now, if the user doesn't exist, what I'm going to do here is I'm going to send kind of a very general error here. And the reason why I don't want to be too specific is, what if somebody is not a legitimate user? They just want to see if you're registered for my site. What if somebody stole your info from like another app's database breach, and they want to check and see if you've got account credentials registered for my site? I don't want to reveal that information. And so if somebody's trying to steal your info, instead of telling them they've got a good email but a bad password, I'm just going to be like, invalid credentials. So what I'll say here is, if we don't have that user object, it means that user's email was not found. So we're going to send a response Our response is going to have a status code of 401. And 401 is one of the two status codes that you'll use. It's going to be the one that you use like 90% of the time. This means unauthenticated. We can't authenticate who you say you are. So this is like, hey, not sure if you're actually legit or not. So the message here is going to say, I'm going to say invalid email password combo. So I don't want to let them know, like at this point, hey, you know, I don't have that email in my database. I just want to keep it vague. So, and for a legitimate user, you know, if they're like, oh no, that's definitely my email, well, they know they screwed up their password. So it's easy for them to kind of figure out. So after this, we've got our user object from the database. So let's say I'm attempting to log in as test@test.com. So we get my entire user object back. So we have user.id, user.email, and user.password, which is the giant mega, you know, hash. So how can we see if our plain text input of password 123, how can we tell if that lines up and if that compares? Well, bcrypt does that work for us. It has this comparison function where we give it the plain text password, we give it the hashed password, and it does all the math for us to ensure like, okay, that actually was created with password 123 as the original input. If you take that, the stored salt, and undergo 2 to the however many amount of rounds. So we don't really have to think about that. The bcrypt library handles that for us. So bcrypt has that compare sync function here. And I kind of hate their variable names, but data here is the plain text password and encrypted is your hash. So plain text password, that's what they're sending in the rect body. You know, I'm attempting to log in with password 123. It's that password variable in the rect body. And the encrypted one is the hashed password that we got from the user object from the database. So that's going to be user.password. And what this compare sync function does is it returns true or false, whether or not, you know, I've got a legit password. And so what I'm going to do here is check to see if this is false. So if not passwords match. And kind of similarly, what if you do have an account? So going back to that theoretical like brute force attack, let's say your info gets stolen from, you know, Twitter or Facebook. They have a massive data breach and they've got your password and email both in plain text revealed. Well, they could come to blurbs here and try that out. And if they, you know, if they want to try like taylor@fowler.dev and they want to see if you've got the same password, if you had a different password for this app, this would fail. But I don't want to say here, you've got a good email, but a bad password. For a legitimate user, they would say, oh, there's an issue logging in. I must have retyped either my email or password. For an attacker, if I don't tell them that it was a good email but bad password, they just don't know if you actually have an account here or not. So if I were to say something vague like, hey, or if I were to say something specific like, hey, you have the right email, just the wrong password, what they're going to do is they're going to focus on your account and say like, hey, we got a potential target here. And they're going to try the top like 100 most common, you know, passwords. And so by being a little too specific with your error message here, you could actually be opening yourself up to some, you know, brute force security issues with your user accounts. So it's for that reason that I am going to use this exact same message copy pasted verbatim. So that way I don't even have like a different, you know, if I had something like this, those are two different strings. A clever enough hacker could maybe after a while figure out that like, hey, if it has email slash password, that means it's a bad email. If it's email ampersand password, they know that it's a valid email and therefore invalid password, and therefore they can try, going for that specific thing. So it's a little weird, but I am, wanting to kind of, throw out some additional auth theory here and talk more about the why we might do certain things. But beyond this point, we know a few things. We've got the plain text email. We know that that user with that email exists because we're able to get past this. And we know that the plain text password that they're sending in the rec.body is the password that we used to originally create that hash. And so for all intents and purposes, our user is logged in. We know who they are, who they say they are. And so what I can do here right now I'll just say like welcome, and I'll bounce their email back. So right now, this is just our way of signifying like, hey, you actually did log in successfully. So let's go set up our login routes to see, our different responses. So add a request. In our login folder, I'm going to call that login. It's going to be a post request to localhost :3000/auth/login. Our rec.body is going to be raw JSON. And then email here. I'm just going to make a fake email here. Or let's say, I am trying to, let's say I am the potential attacker in this scenario, and I'm trying to test your API and see, if somebody does have an account. So I could try to see if like, hey, is Luke registered on this app? Well, here we get invalid email /password combo. So do I know if this is a legit account with just a bad password, or if it's not a valid account at all? No, I can't tell either. And therefore, kind of, stuck, So what about if I flip the script? What if I do have a legit account? So test@test.com. Test@test.com does exist, but its password is password123. If I run this, we are going to get the exact same error message, just in a different spot. Because I don't want to reveal that that is a legitimate user account, they just have the wrong password for it. Because that would say to an attacker like, hey, that account exists, go, attack it, use the 100 top most common passwords on it, see if they use one of those. But otherwise, if everything lines up, I'm using a legitimate email, and I'm using the password that we originally registered with, we get welcome, and then the user's info. So, what do we do beyond this point? Well, after this, we don't really want to send an email and password with every request. That's kind of tedious, and it would just be a terrible process for your users, and it would encourage them to use bad password habits. They had to type the same thing over and over. They might not use a password manager. They might just use something like password123, literally that, for example, because it's easy and short to type and it's not a bunch of special characters. So how do we balance security with convenience? Well, tokens. So tokens are going to be our hotel key cards. And I talked a little bit about the theory of those as well, but, a JWT or a JSON Web Token is just like a hotel key card. Your server creates it, it sticks what it wants into about, that user's credentials, and it packages it up and hands it back to the user. And under the hood, it gets stored in the browser, so your user never has to deal with it. They know that if they type in their email and password and click a button, they're logged in and all their requests downstream are also logged in. So let's go create, a token, our hotel key card, and store our user's information. So what I need to do first is we need to set up some configuration stuff. So in my .env, I just had our database stuff here to get started. But now, we're going to go ahead and add a couple more. And I'm going to set up the secret. This is the password your server effectively uses to sign every single one. And so what I'm going to do is I'm going to use my password manager here just to create a long random string for me. And when you're deploying your app, you always want to make sure that you've got a long, secure random string here, because if somebody can guess your JWT secret, it's effectively like you give them, going back to the hotel analogy, if somebody guesses your JWT secret because you used password or password 123 for it, it's kind of like a hotel leaving the hotel desk unattended. Somebody can just walk up to it and then grab a box of hotel key cards, and they can just make as many hotel key cards for every room they want and just go on a robbery spree, stealing everything from every room. If somebody gets your JWT secret, they can say whoever they are on your app. They can say they're an admin. They can say they're any user that they want. And yeah, so random passwords, and always different when it's local and deployed. Now locally, for testing purposes, we're going to keep this short. I'm keeping it 10 minutes so we can just see it expire. But in a real deployment environment, you might have that set as 15 days or something, just to kind of combat balancing security and convenience. It's not good to have super long JWTs for security's sake, but it's also inconvenient for your users to have to go back to a login screen every 10 minutes or so. So we've got balances that we do because security and convenience are kind of mutually exclusive. So 15 days for just kind of an access token, what we call these, is kind of our sweet spot. Now, in order to create these, we need a library. I'm going to go ahead and install the JSON Web Token library and its types. And while that installs, I'm taking a brief break and I will be right back. All right, so now that we've got our JSON Web Token library installed, let's go import it. It's kind of a pain in the ass to type out JSON Web Token over and over in our code. So typically you'll see people just import it as JWT. I mean, you can, import it as JSON Web Token. It's just tedious to type out over and over. So you'll usually just see it as JWT. So we've got it imported, and now we have to decide what do we want to put in our hotel key card. You don't ever want to put anything secure in a hotel key card, and I'll show you why. Let me go ahead and create one. So to create one, we use the JWT library .sign function. And what we do is we give it usually an object of stuff we want to encode inside of it. So let's say in theory, I put an object with the email and the, user's password in there. In order to securely wrap this up and sign it, our server has to provide a password, aka the token secret or the token private key. When I pause the video, I forgot to update my config file, so we'll come over here. And we have both a secret and an expiration time. And let me just double check. Copy, paste, just to make sure I didn't typo expiration or anything. Okay. So we've got our JSON Web Token variables. Now we can import our config.jwt.secret. So that's how we are signing that. The JSON Web Token library is going to be a little nitpicky. With .env doesn't know if I'm actually going to provide these variables ahead of time. Like, what if I just had my code running like this? Well, if that was my code, where's jwt.secret, coming from? It's not. It's nothing I've defined yet, therefore it's undefined. And so every environment variable you have is either going to be a string or potentially undefined in case you don't have it. And, it's for a good reason, because you might actually forget it or you might typo it, which, in order to prevent that, I copy pasted from my env file to my config just to make sure I had the name spelled right. But, there is a chance that it could not be defined. You'll want to check it, regardless, but what I'm going to do here is effectively just like tell TypeScript to hush and say like, hey, JWT expiration, if I hover over it, it's going to say it's a secret, it's going to say it's either a string or undefined. But by casting secret here as a string, it kind of hushes TypeScript. It's like, no, I promise you it's defined as a string. It's not going to be anything else. So that kind of just like quiets it down. So we do that. It's now happy here. And then we have some extra options. If we leave these options off, your token is going to be infinitely lived forever, which is not a good thing, because that's like if you go to a hotel, they give you a key card, but it never expires. You could go back to your hotel room at any point in the future and use it on the room you previously stayed in, which is very dangerous because, well, I mean, you can have an infinite amount of people using the same room infinitely. So not great. So we need to have an expiration. So there's that expires in property. And then I like to make a variable for it. In production, you could have it as like 15 days or whatever. It's not really secret info. You can actually see that expiration in the token, but I still like to put it in a variable because that lets me say, hey, if I, push this app to a real world cloud app, I'm going to have my value be 15 days, but when I'm testing it on my computer, I want it to be a little shorter. So we'll say 10 minutes. So we do that. And we now have a token, and I'm going to bounce that back. Now, I said some info in here was really, really, really bad to include, like password. You don't ever want anything secure at all in a JWT because it's effectively just translated. So it looks like this is kind of a hash, and it's not really a hash. It's not encrypted, it's encoded. You can think of encoding as just translating to a different language. So this is our object in Spanish, effectively. If you want to think of that as like a two-way translatable relationship. This is stored in a type of encoding called base 64. So we've kind of just converted our object into a big string, but that means we can take that big string and go back to the object. So I can copy our entire token here, and there's a really handy website called jwt.io. That lets you paste a token in there, and it decodes it for you. Can't decrypt it because there actually is, the like actual hash there that your server, signs. But this middle part is the data that we added. So the JWT, if we look at it, you'll notice there are a couple periods here. It's a very special format. The first section, and we use the periods to delineate between the three sections. The first is just saying like what kind of token it is, how it's, set up. The second segment is your actual encoded data. And the third is, the partial hash that your server uses to say like, hey, yes, I was the one who created this token, or like, no, it's a fake token. So here in purple, that's our encoded info in base 64, aka computer Spanish. And we can reverse translate it back here. And oh crap, look at that. I accidentally just, put in secure credentials. Email, that's probably okay to include in a token. Password, anything secure like that, absolutely not, because we can just translate it back if somebody steals your token. So not really good. And I do say steal because like this is something that gets stored in a user's browser. So if a user has a virus on their computer, or if they're using like a malicious Chrome extension or something, they could have this token get stolen. And yeah, so we really don't want to have stuff like that. We also have these two extra things here that I didn't create explicitly, but IAT is issued at, EXP is expiration. If I hover over these timestamps, it says Wednesday, 3:52 p.m. for issued at. Expiration is Wednesday, 4:02 p.m. So we see there's a 10-minute difference, and that's because I set my expiration to 10 minutes. The cool thing about this site is you can like edit stuff over here, and it edits the token back. If I want to check to see if something, like right now we're seeing at the bottom invalid signature. It's saying that because it's trying to say like, hey, what was your token secret? Type it out here and, I'll verify if it can be re-signed. And right now they're saying like, if I had password 123, as my password, this info stays the same. This signature here, dramatically different. If I do password 123 as the, signature here, let's or as the signing key here, let's look at the signature. It begins with 9QKBQ. This is DJ F5N. So if somebody does try to make their own token, if they write their own code, heck, if they even come to this website and just, put their own data in here and they want to pretend like they are admin at, your website.com, your server is going to go, whoa. Yeah, like info in the first two sections is good, but I can't trust it because I cannot take my password and the above info and generate the same signature. So it's a mismatch, meaning, somebody like forged it. So your server would say, first two parts legit, third part signature, nope, it's a forgery. If I want to get this to match up, we have to have the, same signing key. So if I come over here and if I copy my actual JWT secret, which you should never, ever, ever do for a real production thing, just in case this website was actually like stealing these. Well, if we look at that, if I sign this info with the actual signature my server used to sign it, we'll see here that the signature, DJF5N, exactly matches DJF5N. So that's how your server will know that, like, hey, it's either legit or forgery. But, given that we don't want to have that easily compromisable information in there, we are going to get rid of that. What we instead might do is put the ID of the user. And where would we get that? Well, we've got the user object from the database. So user.id would be what we stick in our token. So now we've got something that's like actually safe to store because the ID itself, for your app, it's unique to each user. And, that's not secret info. You could choose to include the email. You could choose to omit it. It's up to you. But the ID is something you definitely want to have. And then, there we are. We see my new token that I just created at 3:58 p.m. expires 4:08 p.m. ID 1. There we go. It's all legit. So we create these, and then our server in some kind of way, validates these. So how? Well, the JSON Web Token library has some corresponding functions that will verify a token's authenticity for us. So let's say, for example, and I'm not using Passport yet because I like teaching the fundamental auth concepts from scratch. So I apologize for the length that this will ultimately end up being and the fact that we're going to do kind of multiple things before we make one comprehensive picture. But imagine I wanted to check a token to make sure it's legit before I allow a post, put, or delete request to come through. So it just kind of depends on your app, as well. You might want to have your GET request public. Really just depends. If it's something like a blog site, you might want to make that stuff a little more private. But if it's something like Blurbs, aka Twitter, where everything is or used to be mostly public, they'll probably have that be public. But anything that changes to the database, post, put, delete, should always, always, always be behind some kind of token check. So how is the token sent? Well, in the login process, your user's not, doing this. They're logging in through your React app, and your React app is going to take this token and store it under the hood. And when it's time to make a request to your server, it's going to try to grab that from under the hood and add it to your request. It's going to add it to your request headers specifically, and to what we call an authentication header. And so if we were to check this on every request individually, it'd be some really ugly code. And I'm going to just show you what that ugly code will look like, which is why we create middlewares instead. But what you would do is say, okay, for my post request, put request, delete request, I want to make sure somebody's got a legit token. Let's go ahead and do that. So I want to make sure that we are sending an authorization header. Yet again, this is something that your browser code is doing behind the scenes for you, or you'll make your code do it. This is not something your users directly have to do. It's also something we can have Postman do for us, but our token is getting sent alongside our request under an auth header. It's going to be sent in a string that has the word bearer, indicating it's a bearer token, which is what JWTs are. It's going to be the word bearer into space and then that. So if auth header does exist, if it's not empty, it should be this. And there is a chance it could be empty, so we do want to validate that. So if there is no auth header, we want to return and say hey, you can't make this post request unless you're sending me credentials. I'm not going to let you walk into a hotel room without a hotel key card. Same thing applies here. I'm not going to let you walk into this post request unless you're presenting some credentials to me. So if you straight up just don't have any, we're immediately rejecting that. After we see that we do have some, once we get to this point, we know we do have an auth header, we can go ahead and check it. We don't really care about the word bearer here. We just want to extract the token out. So what I'm going to do is say, okay, well, it's going to be auth header. And how do we, access that? What we can do is do a string.split on a space here. And so string.split gives us an array of two strings, the word bearer, which we don't care about, and then the actual token itself. And then after that, we'll go ahead and say, okay, well, index position 0 would be the word bearer. Don't care about that. Index position 1 is going to be your token. So now we have our actual JWT that's getting presented behind the scenes. And we need to use a JSON web token library to say whether or not hey, the info is in there is legit, it's not expired, and I'm the one who signed it. So we've got this function called jwt.verify. So we give it the token, we give it our server secret, and our server says, okay, the info's legit, I signed it, we're all good to go. And we are in my, blurbs router here, so I do have to import our config and JWT library imports, because I need to use both of those. All right, so jwt.verify gets the token and then gets our password. And if it's a fake token or if it's expired or whatever for any reason, it's going to throw an error. So we'll catch that. But if it's legit, it's actually going to extract the info out of the token for us. So the user who made the request, we actually know who made that. And so user here would be whatever info is extracted out, which is what we put in there, which I hate their little scroll bar on the side here. Got an object with an ID and an email in it. So if I name that user.email, it's actually going to reflect like who made the request. And then user.id is the ID of the user who, made the request. So pausing this code here, forgetting that we're in the blurbs router, let me just kind of show you our info getting bounced back. So that user that we're returning here is going to be like the decoded token. Like our server's like, yeah, this user's legit. Here's their info. So let's go make a request. And so with Postman, how we can, get this stuff set up behind the scenes, not too bad. You're going to copy your token. And since I'm in my, blurbs request folder, I need to go ahead and make my API folder. In there, make a blurbs folder. And I'm going to make a new post request to create a blurb. So it's going to be a localhost :3000/API/blurbs. So with Postman, usually the only tab you're using is body to add your data. I've got an extra one here called authorization down to type. Do bearer token. I've got some older ones already in here from by default, but I'll paste that new one we just used. And now, let's see. Let me go look at my code real quick. Okay, yeah. Actually, let me do no auth. If I send this request without auth, I didn't save my code. Whoops. Yep. So my code's not saved. All right. It's going to yell at me and say like, hey, you're not sending any auth. You're not giving me a hotel key card. I'm not even going to bother giving you the time of day. Like, go away until you give me some actual stuff. So now I switch it back to bearer token. We send our JWT. And it's going to say, hey, we successfully verified it. Here's your user's information, the email, and the ID of the user who made the request. So it's pretty cool because I was able to log in. My server is able to grant me this secure token, and our code over here is able to successfully verify that. And if we wait, since I did log in a few minutes ago, let's see, what's that expiration time? 4:08. Yeah, we actually might be expired now. Yes, we are by a few seconds. Holy cow, I must have literally just missed that by a few seconds. So if I try to make this request again, what's going to happen is my verification is going to fail, and it's because my token's expired. So we'll just get a general 500 here. cannot create a blurb at this time. But if we look at the error, it's going to say, hey, we've got what's called a token expired error. It's saying JWT expired. It's even telling us the timestamp it expired at. So, this is showing me that, hey, not only can I validate that it's a good legitimate token, but it's also not one that lives forever. So like your hotel key card, if you go to a hotel 2 months after you stay there and you try to use it, you'd be running into something like this. It's gonna be like, hey, that's definitely not valid anymore. We've set a firm expiration time. So we know that's working now. And so at this point in time, that lets us know like everything is great if we can hit that. So beyond this point, we know who the user is. And therefore, I can kind of return back to our default code where we're actually creating some stuff. And then our user ID here, instead of hard coding it as 1, we know who made the request. We've got their account credentials here in this user object. Now, we don't have a type to say what user represents here because of JSON Web Token, format. You can put literally whatever you want in an object. So it doesn't actually know what user can be. So we need to be able to say like, hey, this JWT payload type, it's actually going to be like my own specific thing, what I say it's going to be. I'm going to come over to our types here. And I'm going to create one called payload, which is just kind of a general term for the, contents of the token, the payload. So what did we put in there? Number and email. So we've created that interface. And what I'm going to do is come over to here. And when we run jwt.verify, we're going to tell TypeScript, hey, this data is getting returned as our payload type. So it understands that user is an object with an ID and email property. And so beyond this point, since we actually know who made the request, we can use their ID to make for the new blurb. And so now instead of it just being hard-coded 1, if I logged in as user 2, it would create it as user 2. If I did it as user 3, it would do it as user 3. So let's actually finally now go create some blurbs and, get to the point of like, okay, my backend auth, it's, working. So right now, token's expired, can't do anything at the moment. So my first account, test.test.com, I'm going to go log back in. I've got some new unexpired credentials. And this might seem tedious right now, but yet again, this is all happening. Your code's taking care of this for you under the hood in your browser with your React code. So like your users aren't going to be any the wiser. But for us with Postman, especially since I have such a short-lived thing, we are going to be doing it manually. But we now can create a blurb. And I accidentally created one earlier before I saved my code, so my IDs aren't matching up. There we go. And so here I am as user number 1, creating blurbs 1, 2, 3, 4. Let me go log in as a different user now. I'm going to log in as test2 at test.com. Completely different user account. We got our welcome message here saying like, welcome test2 at test.com. So it got my credentials correctly. And then I'm going to take this token, which is user number 2's hotel key card effectively. I'm going to go to my create function, and under the hood in my browser, this token would be presented instead saying like, okay, this is user number 2 on a different, account making that. So even though I'm not sending user ID here in my object, if we go look at my database, if we go look at blurbs, we see that blurbs 1 through 4 were made by user number 1, but I just logged in as user number 3. and made blurb number 5. And so we are now able to validate, we are who we say we are. If we weren't using that JWT validation code, I am logged in as user number 3 right now. But if we were taking that data from the rec.body, we can't trust this because I can just say whatever number I want here. I'm user number 3. And if I were trusting the data in the rec body, I could just impersonate, whoever. So can't trust that. But since the token is secure, since if a user changes it in any way, if they don't have the password to sign it, your server is like, oh, that's a total forgery. Well, they can't change who they say they are effectively. And that allows us to, actually authenticate our users before that. Now, this is really freaking tedious. And you would have to write all of this code on every request you want to check to see if somebody's logged in or not. It's really tedious because we would have to do this for every post, every put, every delete. It's the exact same repetitive code. So instead of doing this crap here, middlewares. That's where they come into play. And so yet again, I know that we're using Passport, but I'm pretending like we're not. I'm just approaching Auth from scratch first so we can dive into the core fundamentals. And then, let's see. We're going to write something that looks a lot like an express function. It's going to look like an express function just if I copy pasted this part out of like a router.get or something. But we are effectively going to just take this code I had here. Paste it here. I need to get all my other imports. So we'll import the JSON Web Token library. We'll import our config. And we need to be able to type, what rec, res, next are. Those are all parts of Express. If I hover over rec, it's this giant, super long Express, type. Same with res, it's the Express response, long type. There's also the next function here that we haven't used in a while, but its type is actually called next function. We need all of those in here, and so we could copy paste those types from Express. So this would be like rec : express.request, all that stuff, res, response, next function. Or here, we can call this function an express request handler. And a request handler is, as the name sounds, a handler function for an express request, which types the rec, res, and next function for us automatically. So I didn't type those. They were any beforehand. But if I type token check as a whole, it automatically types those 3 arguments for us. So it understands what all of this rec and res stuff is. Now, let me import my payload type. Now, how can we have this be useful? Actually, let me do this. Set up a try catch here, since if it's a bad token for any reason, it throws an error. This is most commonly going to get hit because somebody, is logged out, your token's expired or whatever. But we'll go ahead and do that. Log out our error. And now, just like before, we kind of mostly just moved the code we had in this file over into its own separate function called token check. The one important thing from this is that on line 48, this user variable that is the user who made the request. We can trust this data. We know that is the user who made the request. Well, how can we make this, be useful in downstream requests? Well, what we can do is we can actually inject something else into the express request object. I can take the express request object and add a property called pizza if I wanted to. TypeScript's going to be mad at me because rec.pizza doesn't exist, but if we ignore the TS, errors temporarily, I can inject a property called pizza in it and then call the next function. And, if you remember back to your first Express lab where you created your first middleware, you basically had this code here. You just did it inline. All we're doing is saving this. And, when I say inline, you were just like logging out the rec.method and rec.original URL. All we're doing is a little bit more stuff here, but I'm saving it to a variable. And the important thing about that is that a variable can be exported and imported and reused over and over and over again. And so right now it's a little mad because it doesn't know what rec.pizza is, but if we temporarily, ignore that, I'm going to what I'm going to do is I'm actually going to freeze all my actual post request code below. So all we're going to do is we're going to have our code here. First, filter through token check. So how do we get it to go through that token checking logic? Well, with Express, with middlewares, everything's kind of like a series of, filters and funnels. We can import token check, that function here, and remembering that it was like a rec.res.next function. What's this? The exact same thing. With Express, you can keep on, adding things in front of the other as long as you keep telling next to go to the next thing in line once that first thing's done. That's exactly what we do in token check. In token check, if something's broken, we send a response, but if nothing's broken, we allow it to go to the next thing in line. So this. So if my token is good, which it might be expired now because I talk a lot, if my token's good, we'll actually be able to get here and I'll bounce back this info user who made the request because I extracted it out of rec.pizza, just something I arbitrarily made up and injected. If my token is bad for any reason, well, this does all that checking for us. All I had to do was slap this one bad boy in front of my post request, and now it's making sure that, I can't even touch this code unless I've got a good token. So let's go test it out. And cool, I'm not expired. Probably barely, but, now I make a post request, and even though I don't have this code to check the token directly inside of this file, we're still filtering through it. And in there, injecting something called rec.pizza, and here we're extracting that info out. So we're able to see who made the request as long as it filters through token check, which is cool because now we can slap that in front of everything that modifies the database, our put, delete, and post, and that requires you have to be logged in. Now, all these typings are all going to be pretty fucked up. And so what we need to do is we need to tell Express effectively, hey, rec.pizza exists. Or how about something that semantically makes better sense like rec.user, the user who made the request. So in our types, we kind of have to hijack Express's types. And I'm doing authentication from scratch here yet again. With Passport, I'll be changing this up a little bit, but here I'm kind of just focusing on core auth fundamentals. And so what we're going to do is we're going to write this. We're going to say declare global. And what this is going to do is this is going to create a type in every server-side file we write that type's going to be available automatically and automatically applied, but only under files that are, utilizing Express. So we're saying like, hey, I'm making a type that kind of hijacks all other types of the same name, but only if it's part of Express. And what we're going to do is we're going to hijack the Express request type. And what we're going to say here to match the code that I currently have is, let's say, hey, we've got rec.pizza being a thing. What's rec.pizza? It's that, payload object. So I know I'm using kind of this nonsensical name, but I just want to show that association. And here, like, oh shit, check it out. We've got rec.pizza getting recognized. And if I want to, see the user's email, here rec.pizza is the user who made the request, and we have rec.pizza.email, rec.pizza.id. So terrible nomenclature, doesn't make sense to keep it that way. Did that for demonstrative sake, but rec.user makes sense. It's the user who made the request. So here, before passport, this is what we've done. We've now successfully modified that. And so now here, rec.user is user. Here, rec.user, you get all of our info that way. But yeah, for our post request, now, our user ID. Going back to our legitimate code, who made this request? Well, the request.user. And I want their ID specifically to put in my database, so request.user.id. It's not anything I send in the rec body. It's something that is part of who I am. That info is derived from the token, so my server can trust this. And so now, we know who made the request, we know who created the blurb. Cannot be modified by the user. And then for put and delete, we don't really need the ID of the user itself. ID for the put and delete here is referring to the blurb itself, but not the user. We don't really need that at this point. We can for additional extra features downstream, but we do need to make sure we at least filter through token check, because that makes sure that we, 1, have a token, 2, that it's not a forgery, 3, that it's not expired, and 4, that it's actually got the info in it that we need. So that's the beauty of these middlewares, is they do a lot of heavy lifting for us that we can just reuse. And so, like I said, as a deliberate design choice, I left my GET requests here as public. However, if you want, you can also hide those behind token check, and so that way you have to be a logged in user of the site in order to see these blurbs. But that is it for Auth from scratch on the API. The next video I'm doing is going to be translating this over into passport terms specifically. So I will see you there.